2. Today we're going to talk about section 2.3 on long division and syntactic division. That's the main topic, long division and syntactic division. So first of all, we will learn how to use a long division to divide polynomial by other polynomials. Okay. For example, it could be like dividing x squared minus 3x, adding 4, dividing by x minus 2. Okay. That could be a typical example of dividing a polynomial function by a polynomial function using long division, right? And also we're going to learn how to use a syntactic division to divide polynomial by another polynomial in this form. And also we're going to take a look at remainder theorem and also the factor theorem. So first of all, let's take a look at long division of the polynomial function. Okay. Long division is basically just like any long division. If you're dividing 143 by 15, typically you just write it as long division, 143 by 15. So 15 going to 143, it's 9 times. 9 times 5, 45. 15 times 9, 45, carry 4 over, turn out to be 135. Okay, so the remainder is 8. So typically you write it as quotient 9, remainder 8 over divisor 15. Okay, so that's how we conduct the long division in terms of number wise. But now let's take a look at how we divide in a polynomial by another polynomial using long division. For example, let's say f of x equal to 6x cubed minus 19x squared plus 16x minus 4. And if you look at the graph, this is the graph of the function. So basically the graph have 3 intercepts right here. So meaning we have 3 zeros, right? 3 zeros. This third power indicates we have 3 zeros. So we have a 0 at 2 and then 0 between, and there's a couple zeros between 0 and 1. So typically you could write a function as x minus 2 times a quotient as a function of x. So typically in order to find the q of x, we're using long division. Okay, so now next slide, I'm going to show you how to do the long division. So typically if you conduct a long division, you just put a dividend, right? This is what we call a dividend. X minus 2 is what we call a divisor. So we're going to put a dividend inside the division side. 6x cubed minus 19x squared plus 16x minus 4, and dividing by x minus 2. So step 1, you take couple terms, right? And also you take couple terms. Step 1, you're taking leading term 6x cubed, dividing by the leading term from the divisor x, and turn out to be, you divide into that, you get 6x squared. So right here, put 6x squared on top. Now, step 2, you multiply 6x squared by divisor, and then you distribute it, right? Right here, distribute it. You get a 6x cubed minus 12x squared. Now, you copy those two terms, put it underneath the first couple terms. Okay, and then put minus sign in front of it. Now you simplify, 6x cubed get cancelled. And minus 19x squared you can put it on the side. Minus minus, these two minus become positive, plus 12x squared. And you combine them, you get negative 7x squared. Now remainder is negative 7x squared. Now you carry down another term, meaning carry down 16x. Now you continue this process by dividing negative 7x squared divided by x, and the quotient becomes negative 7x. And negative 7x is what we put up here. Okay. So now similarly, you multiply negative 7x by x minus 2. Distribute it, you get negative 7x squared plus 14x. Alright, that's what we put down here. Minus 7x squared plus 14x. Now again, we subtract it. Now similarly, we cancel this negative 7x squared. Now we get 16x minus 14x, and we get 2x as remainder. 2x goes here. And again, carry down the minus 4. Now again, dividing x into 2x, you're gonna get positive 2 right here. 2 times x minus 2 will become 2x minus 4. As you can see, the remainder will be 0. That means x equal to 2 is the 0 of this particular polynomial function. All right, and that's how you typically conduct a long division. Okay, so from this long division, you can see that conclude that 6x cubed minus 19x squared plus 16x minus 4 is equal to x minus 2 times 6x squared minus 7x plus 2. And right here, we can further factor in 6x squared minus 7x plus 2 using the method I showed you guys a while ago. This could be factored as 2x, 3x. And we need to get minus 7x in the middle, so minus 2, minus 1. Now we cross multiplying, you get minus 3x, minus 4x. That turns out with minus 7x. Okay. So we secure the first term, 6x squared right here. Secure last term, minus 1 times minus 2 becomes positive 2. And middle term secure right here, so we get a proper factoring. So it should be x minus 2 times 2x minus 1 times 3x minus 2. Okay. So basically from the previous example, we know that x minus 2 is a factor of this polynomial function. And then long division yields a remainder of 0. That tells us x equal to 2 is a real 0 of f of x equal to 6x cubed minus 19x squared plus 16x minus 4. And now let's look at another example. We continue using the long division. We want to divide this second degree polynomial function by first degree polynomial function. So similarly, we're going to use a long division, x squared plus 3x. And then key thing is you should double check there's no missing term here. So for a similar procedure, we take two terms, dividing the leading term by the leading term, divide leading term from the dividend by the leading term from the divisor, and turn out to be x. So put x right here and multiply x by x plus 1. You get x squared plus 1x. Now you find the difference. Then cancel x squared, 3x minus plus is minus 1x, gives 2x. And now carry down to positive 5. And x going to 2x. (2x by x) give us 2. That means we're going to put positive 2 right here. After that, multiply positive 2 by x plus 1 give us 2x plus 2. Now you find the difference. Right, subtract it. 5 minus 2 gives us 3. So for this particular example, when dividing x squared plus 3x plus 5 by x plus 1, you should write the answer like quotient x plus 2 plus remainder 3. This is remainder over the divisor. This is a divisor. X plus 1. And that's how we write the result. Right? Quotient plus remainder over divisor. Very typical, long division process to get to the remainder and divisor at the same time. So you can write a result like this. Like what I did earlier, right? Okay. So now let's take a look at the division algorithm. So anytime if you're dividing a polynomial function, f of x, by d of x, you're always going to get a quotient, q of x, plus remainder as function of x over divisor, d of x. Okay, and that's a basic structure of long division. And here q of x is what we call the quotient. R of x is remainder. D of x is divisor. And then f of x is dividend. That's basically what the division algorithm look like. I just try to explain it to you. And sometimes f of x over dx is improper because the degree of the f of x is always greater than or equal to degree of the d of x. And typically r of x over d of x, meaning remainder over divisor, is always proper fraction because the degree of r of x is always less than the degree of d of x. So before you apply the division algorithm, follow two steps. Write the dividend and divisor in descending power of the variable. Also insert placeholders with a 0 coefficient for missing powers of the variables. For example, if you're dividing x to the 4th plus 2x squared plus 3x plus 1 by x minus 2, for example. Right? So if you look at the dividend here, there's a missing term. The missing term is 0x cubed plus 2x squared plus 3x plus 1. So you definitely need to insert this missing term here. So then you can carry on with the long division. So the missing term is very crucial to be put back in the dividend. Now let's take a look at syntactic division. So typical syntactic division is a shorter version. Syntactic division is the simplified version of long division. That being said, so if you have a dividing this polynomial function by another polynomial function, so basically just put a coefficient in the front, right here. Just copy all the coefficient, including a sign, and put a k in front of all the coefficient. Now we do this, we just carry over the first coefficient, and after that we multiply the k by the leading coefficient to get ka. Then we add in this. So vertically we adding all the numbers here. Horizontally we just bring down all this result as a remainder. Alright, so now let's take a look at the actual example. Alright. So let's say we want to use a syntactic division to divide this x to the fourth minus 10x squared minus 2x plus 4 by x plus 3. So right here, that's missing term. That means we get to put it back. X to the fourth plus 0x cubed minus 10x squared minus 2x plus 4. So missing term is 0x cubed. And by this x plus 3, so this is our divisor. So in order to apply the syntactic division, look at this. And we're going to copy all these coefficients. So in front of x to the fourth, by default, that's 1. So 1, 0, minus 10, minus 2. Then plus 4 in the back. Okay. So now technically, and the k here should be negative 3. And so typically, in order to get a k, you're just setting x plus 3 equals 0, right? And then solve for x. And that's how you get k. So minus 3 from both sides of the equation, so get x equal to negative 3. That means k equal to negative 3. And negative 3 is what we put up here. Now once you get that, we can start the process. So step 1, you carry down the 1. Step 2, you multiply negative 3 by 1, you get negative 3 right here. Now you're adding those two numbers. Okay, 0 plus negative 3 give us negative 3. Okay, so negative 3 vertically, so this is diagonally, you multiply negative 3 by negative 3, you end up with positive 9. Okay, now again you adding these two numbers vertically, you can end up with the minus 1. So negative 3 times negative 1 becomes positive 3. Again, you combine these two numbers, you end up with positive 1. Now multiply diagonally, negative 3 times positive 1 is negative 3. Combine them, you get positive 1. So that means this is our quotient here. This is our remainder. So if you look at it, x to the fourth dividing by x, so the quotient for the leading term should be x cubed. So it should be, when you divide this two, it becomes 1x cubed minus 3x squared minus 1x plus 1. And the remainder should be 1 over the divisor x plus 3. That's how you translate this, the result of syntactic division into the quotient remainder. And similarly, so it should be x cubed minus 3x squared minus x plus 1 over x plus 3. You can also confirm this using long division. So that division is a shorter version or simplified version of the long division. So you guys could try that on your own, using long division to verify the result of that division. But yeah, that's typical procedure on how to apply the that division. And this is a solution right from the previous step. Just confirm with our calculation. And now the very last topic in this chapter is remainder and then factor theorem. So remainder theorem states that a remainder obtained in that division process has important interpretation. So using remainder theorem to analyze it. So basically, the remainder is the same thing as f of k. So for example, the previous example, the remainder is 1. So that means if you try, let's copy the function here. X to the fourth minus 10x squared minus 2x plus 4 over x plus 3. We know that remainder is 1. Now if you look at, see here, k is -3. You look at f of -3. According to remainder theorem, f of -3 should be 1, but then let's double check it, right? So right here, you just replace this x is -3, goes here, goes here, goes here. So you look at -3 to the 4th power minus 10 times 3 to the 2nd power minus 2 times -3 plus 4. And -3 to the 4th power is 81 minus this is 9. 10 times 9, 90 plus 6 plus 4. So if you look at it, it should be 81 minus 90 plus 10. So this is exactly 91 minus 90, and that's exactly 1. So basically what this remainder theorem states is remainder is the same thing as f of k. So here k is -3. Okay, so that's a remainder theorem. So apply the remainder theorem. So the remainder of this function, when this function dividing by x cubed plus ax squared plus 5x minus 7 by x plus 2. Let's see what that remainder is. So if x equals -2, that means the factor itself should be x plus 2. You could just also look at it as, x equals -2, right? If you're adding 2 from both sides, you get a factor. So f factor should be x plus 2 equal to 0. So x plus 2 should be the factor. So remainder here should be f of -2. Okay. So f of -2 should be 3 times -2 to the 3rd power plus 8 times -2 squared plus 5 times -2 minus 7. So this is 3 times -8 plus 8 times 4 minus 10 minus 7. So this is -24 plus 32 minus 10 minus 7. This is 8 minus 10 minus 7 Negative 2 minus 7. So remainder should be negative 9. So if you apply the long division of synthetic division, you should get that. Maybe let's quickly apply the synthetic division to check it. So carry all those coefficients. 3, 8, 5, negative 7. So k here is negative 2. So negative 2 goes here. Carry down the first number. Multiply diagonally. Again, negative 6. Adding vertically, you get positive 2. Again, multiply diagonally, you get minus 4. Adding them, you get positive 1. Negative 2 times positive 1 is negative 2. When you combine them, you get negative 9. As you can see, this is remainder. Remainder should be negative 9. So according to remainder theorem, you also get the same results, right? So that's how you utilize remainder theorem to get a remainder fairly quickly. And a factor theorem. So if let's say a polynomial has a factor of x minus k, that means if and only if f of k equals 0. Meaning there's no remainder, then it gotta be a factor, right? Otherwise, it won't be a factor. If the remainder is not 0, then it's not a factor. So if the remainder is 0, then x minus k is a factor. That's what is said. So for example, we show that x minus 2 and x plus 3 are factors of f of x equals 2x to the 4th plus 7x cubed minus 4x squared minus 27x minus 18. So here for the first factor, you take out the first factor. And here solve for x equal to 2. Okay. So that means f of 2 must be equal to 0. So let's check it. 2 times two to the 4th power minus 7 times 2 to the 3rd power minus 4 times 2 to the 2nd power minus 27 times 2 minus 18. So if you expand it, this is 2 times 16 minus 7 times 8 minus 4 times 4 minus 54 minus 18. So this is 12, no, 32, right? This is 16, so it should be 32. Minus 56, minus 16, minus 54, minus 18. Now this is plus, okay. Plus 56. So right here we get a 88 minus, this is 70 minus 18. That's exactly 0. So that proves x minus 2 is a factor of this function f of x. Similarly, for x plus 3, we do the same thing. We just find out what is f of negative 3. So we plug into the function and then verify that the result should be equal to 0. Right? As soon as that's verified, then we know that x plus 3 is also a factor. So basically, once we confirm that remaining factor could be factor as this. So it's x minus 2, x plus 3, and then the remaining factor could be factor into this. 2x squared plus 5x minus 3 plus 3. Typically, you can factor like this. 2 goes here. 3. positive. And if you cross multiply, you get a 2x plus 3x. That's 5x. Okay. That matches middle term. So 2x plus 3, x plus 1. Since it's fourth degree polynomial function, so we have 4 different zeros, and all these zeros turn out to be 2, -3. This is -3/2. The last one is -1. Okay, so that's everything on section 2.3.